Hello class, welcome to this video on chapter 8, lesson 1 for geometry. We're looking at dilations today. So how do we transform a figure using dilations? So a dilation is remember that we discussed in a previous chapter the idea of a rigid transformation. Now a rigid transformation is something that preserves the distances or the sides of a figure. Okay, so in other words, um, what it does is it maps a pre-image onto an image while maintaining the sides. Okay, so it maps a pre-image, which is the original image, onto a new figure called the image, right? That's what all transformations do. However, in a rigid transformation, when the pre-image goes to the image, both of them are congruent. Okay, whereas in a non-rigid transformation, that is not necessarily the case. So, in other words, a non-rigid transformation is a transformation that changes the dimensions of a given figure. And a dilation is one such non-rigid transformation. And so what it does is it enlarges or reduces the geometric figure. So when a figure is enlarged or reduced, the sides are proportional to the sides of the original figure. And what we mean by proportional is if you reduce the side by or the figure by half, then that means all of the sides are going to be reduced by half. That's what we mean by proportional. Okay, so now the center of dilation is the center point from which dilations are performed. The scale factor of the dilation is the ratio of the length on an image to the corresponding length on the pre-image. Okay, and usually we use the letter K for that. Okay, so in other words, the center of dilation K, or the scale factor K, is equal to the length of the image divided by the length of the pre-image. Okay. So length, and I'm going to put in parentheses image over the length pre-image. Okay, and this is one such formula. This is the formula that we're going to use for finding the scale factor. Okay, so the value k determines whether the dilation is an enlargement or reduction. So a dilation with a scale factor that is greater than 1. So if this scale factor is greater than 1, then we refer to it as an enlargement. If the well, an enlargement means that the image is larger than the original figure, and if you have a scale factor between 0 and 1, then that's going to produce a reduction where the image is smaller than the original. Okay, so let's look at an example of this. So it says identify a dilation to find the scale factor. So it says determine whether the dilation from triangle ABC to triangle DEF is an enlargement or reduction. Then find the scale factor. All right, so we're going from the left to the right here, ABC to DEF, according to this description, right? So the scale factor. So what we want to do is calculate K, right? Which K, remember, is image over pre-image. So in this case, we have the image, which is 2. The 2 is the image, right? And then the pre-image is 6. So in this case, to get K, we took DE and we divided it by AB. Okay, because DE is the pre-image, right? So this is the the image, not pre-image. This is the image, and this is the pre-image. Okay? All right, so we got that. And then 2 over 6 is 1/3. Okay, so the scale factor is 1/3. Okay, so notice that in this case, we're going from left to right, and so this is a reduction because the image got smaller, right? Since triangle DEF is smaller than that triangle, then it has to be a reduction, okay? And so we found the scale factor for that. And notice that 1/3 is between 0 and 1, right? So 1/3 is between 0 and 1, and that's why we refer to it as a reduction. Okay, pause the video and see if you can try the check to the right. Right, hopefully you tried it. So let's look at it. So determine whether the dilation from the figure on the left to the figure on the right. So you're going from there to there. On the right is an enlargement or a reduction. Okay, so that means that this is the pre-image, and this is the image. Notice that the image is smaller than the original, right? And so this has to be a reduction, right? So, so the image is smaller. That means we have, so the image is smaller than the original, right? Original image. So we have a reduction. Okay, so we have a reduction, and then we have to go image divided by pre-image. Okay, so we're going to take the image here and divide it by the pre-image there. Okay, so K is equal to image over pre-image. There you go. And we can divide this by 2. No, we can divide it actually divide it by 3. And that will give us 2/3. All right, and that's it for that one. So let's look at example 2. Find and use a scale factor. Jalal is printing a banner for school's wheelchair tennis team based on the design shown below. By what percent should Jalal enlarge his design so that the dimensions of the banner are 5 times that of the original? What will be the dimensions of the banner? Okay. So again, he wants to enlarge it. So this is an enlargement. This is a dilation, right? And the scale factor is 5. Okay, so the scale factor here is 5. So that means we got our K. So K equals 5. So it says by what percent. So if you're multiplying everything by 5, right, which is what you're going to do, you're going to make it 5 times bigger. Then that means it's a scale factor of, in terms of percent, it will be 500%. Okay, 5 times 100. If the scale factor is 2, then it's 200%. Right? If scale factor is 3, it's 300%, so on and so forth. So that's what it'd be like as a percent. If the scale factor were a half, well, then a half is 0.50, right? And 0.50 would be 50% scale factor. Okay, so that's basically how you do it. So now we can find the dimensions of the enlarged image using the scale factor. So all we're going to do is we're going to do 6 times 5. Okay, so we're going to do 6 times 5. Because 5 is the same thing as 500%, which is going to be 30 inches. Okay, and then 14 times 5 is 70 inches. All right, and then so there you go. The banner will be 30 inches by 70 inches. That's it. Pretty simple. Okay. All right, dilations on the coordinate plane. On the coordinate plane, a dilation is a function that involves multiplying by a scale factor. And you can see that's what we did, right? The scale factor was 5, and so therefore we would multiply these by 5. So this would be 6 times k, and this would be 14 times k, right? So notice that we did that, 6 times k here, and then we did 14 times k there. Okay, it's the same idea. So we multiplied by the scale factor in order to get the result. In the same way, we're going to multiply by the scale factor of k, and that's going to define help us find the coordinates of the vertices of the image. Okay, so to dilate a figure by a scale factor of k with respect to the origin. Okay, so this is important. Is that the origin is your center of dilation. Okay, it's where you're dilating from. So what I like to think of it as, I like to think of it as if I have a shape, right, that I want to dilate from. Let's just say this is the shape, and this is the center of dilation. Okay, so this is the center. Well, I like to think of it as putting a pin there. So imagine that you put a pin there, like a thumbtack. Let me make it a different color. So imagine that you put like a thumbtack there. All right, and then you put a string from there to each of the um, points on the original figure, and this represents a string. Okay, like that. And so then, therefore, what you're doing is you're taking this string and you're either stretching it and making a dilation, or you're shrinking it and producing a reduction. Okay, so hopefully that made sense. So if I were to increase this, let me show you this picture. Okay, this is really this concept is pretty important to understand. So let me make some more room here. So let's say I wanted to increase it by 2 times. So let's say I have a scale factor of 2. Well, then what I'm going to do is I'm going to stretch the string by 2 times bigger. Okay. So right now this is 1. I don't want to do it in. Okay. So right now this is 1. And this is about 2. See that? There's 2 strings of the same length. So now the string is 2 times longer than it was before. And this is where this coordinate goes. And now for this one, this is going to be 1, and then here, that's about another string length. You see that? And that's where this point goes. And then here, I'm going to do, this is going to be 1. And then let's double that. Okay, so let's continue doing that. That looks about double, right? Kind of. So that's about another string length. You see that? I'm doubling whatever the string length is from the middle, the center, to that, to where the thumbtack is. And that allows me to stretch or shrink. And then there you go. So now I have this point right here. And then if I draw the image, right, which I will do in blue here, I will get something like this. Not a very good line. And there you go. And notice that this is twice as large as that. And that's because we did a scale factor of 2 where we doubled the string length. You see that? That's what a dilation looks like from the center out where you're to the figure where you're trying to stretch it. Okay, that concept is really important that you need to understand. When you're doing this is what you're physically doing, or graphically doing, visually. All right, so to dilate a figure by a scale factor of k with respect to the origin, multiply. All you got to do is multiply the x and y coordinate by the vertex. Okay, so of each vertex by k. All right, so you're going to take the x coordinate, multiply by k. You're going to take the y coordinate and multiply by k, and that's all there is to it. For the dilation about the origin. Now, the dilation about something that is not the origin is going to be different. So basically, what we're going to do is to dilate it, what we need to do is take the figure. So let's say I have the same figure or something similar to what I drew earlier. All right? What we're going to do is, let's say I want to dilate it by here. Let's say that's the center. So let's call that XY, right? Oh no, we're going to call that center AB. So let me call that AB. All right. So let's say that's the center. Let me call this a center. Okay. that means I'm going to stretch the figure from there. And so what I'm going to do is I'm going to move this to the left and down. And by moving it, it becomes negative. I need to move it by negative A, negative B. Okay, so I need to move it to the left A and to the left B. Okay, so minus A and minus B. Okay, and that's my vector. So there's the vector right there, negative A, negative B. And that's where this comes from. You see that there? That's where that comes from. And then we're gonna perform the dilation, right? Which is the dilation is K. Then we're gonna perform the dilation, and then guess what? We're gonna move it back. Okay, so we're gonna move it back to where it was. So it's gonna be plus B, and it's gonna be plus A. And when we do that, so this is going to be plus A plus B, and that's where that comes from. And then of course we did the dilation. The dilation was K, right? So let me just do that there. Okay, so again, first step, we move it to the left and down so that we can move it to the origin. And then so that'll be the minus A and minus B. And then we dilate it, which is K, right? And then we move it back. Okay, so let me just put here, when we move it here, we're going to dilate it. And then we're going to move it up and to the right, basically back where it was. Okay, and that's what you have here. So basically, I mean, if you don't completely understand that, that's fine. We're going to use this formula, but this is where the formula comes from, right? It's that idea. So example 3, triangle TRS has the following coordinates. Find the coordinates of the vertices of T prime, R prime, S prime after each dilation. Okay, so we have a couple dilations here, so let's do the first one. So we're centering about the origin right here. So K is 1/2. Remember, the origin is Kx times Ky. So all we got to do is multiply the x coordinate by K and the y coordinate by K. And K is 1/2. So we're going to do 1/2 x, 1/2 y. Okay? There is my coordinate rule for this particular problem. All right, and then we can go ahead and multiply these. So we're going to do negative 4 is the x coordinate times 1/2, or sorry, let me just do the 1/2 first. 1/2 times negative 4. We got 1/2 times negative 5. And that's going to be negative 1/2 times negative 4 is negative 2. 1/2 times negative 5 is just going to be negative 5 over 2. All right, and then here, going to do the same thing. So 1/2 times 0, and then 1/2 times 6. And you get 0, and 1/2 times 6 is 3. All right, and then last one here, so 1/2 times 4, 1/2 times 3, and so this could be half of 4 is 2, half of 3 is just going to be 3. I'm just going to write it as 3 over 2, or 1.5. All right, so let's look at the next one. So part B, it says centered at R, K equals 3. So now notice that this here is a reduction, right? The coordinates got smaller. This here is going to be an enlargement. It's going to be 3 times as large, a 300% increase in the size, and it's centered at R. So R is this point right here. Okay, so that means that this R that you see here is going to be my coordinates. So let me write that here. So that means that R, which is 0, 6, right? That's going to be my A, and that's going to be my B. This is going to be A and B. All right, so remember that in the formula that we had here, right? We're going to use A and B, and then we know that the constant K is, here I have it in blue, is 3. And now X and Y are just going to be the whatever coordinates we're interested in. So let's go ahead and apply this rule. So we have here for the rule, XY maps onto 3 times X minus A. Now A is 0. And then plus A, and A is 0.
comma. Now we have, and this is in parentheses, of course, so let me put this in parentheses like that. Now we have k, which is 3, times parentheses x minus, now b is 6 here. So x minus 6 plus 6. There you go. All right, so then in other words, this x minus 0 is just x, and anything plus 0, the 0 doesn't do anything. So here on the left coordinate, we got 3x. On the y coordinate, we got 3 times x minus 6 plus 6, right? So I'm going to go ahead and do that over here off to the side. I'm going to distribute. So if I distribute this, I get 3x minus 18 plus 6. And negative 18 plus 6 is negative 12. So this becomes 3x minus 12. All right, there's my transformation, guys. So xy goes to 3x minus 12. So now we're going to apply this transformation. So we have x is negative 4, so we're going to replace it. So negative 4. And then for the y coordinate is negative 5. So we got, oh, and I put x here. This should say y, not x. So I apologize for that. Let me just change that to a y. Sometimes I do my x's and they kind of look like y's, and then I end up changing them to x's. So this should be a 3y. Okay, so sorry about that. 3y. All right, that's what it says here. We got x and we got y. All right, so 3y minus 12. So now the y, so this is x, this is y, right? So y is negative 5 and minus 12. So we get negative 12, comma, and then negative 15 minus 12 is negative 27. All right, so now when I do the r coordinate, now this time, notice that since I am centering at r, that means r is not going to move at all. Okay, so r should stay the same, 0, 6. So we know it's going to end up that way. However, we're going to use the formula to show you that, but we know it's going to be 0, 6 when we do this. Okay, all right, so let's go ahead and plug it in. So we got, it's 3x and then 3y minus 12. So this is x and this is y, right? So we got 3 times 0, and then 3 times 6 minus 12. So we have 0, comma, and then 18 minus 12 is 6. There you go. See, I told you it would be the same. All right, so again, do the same thing here. So we get 3 times 4, comma, and then 3 times 3 minus 12. We have 12, comma, and then 9 minus 12 is negative 3. All right, those are my coordinates, guys. No graphing necessary. We have the coordinate rule. We can just use it. All right, pause the video and see if you can attempt the same type of problem. All right, so hopefully you paused it. Let's take a look at the problems. So we got triangle XYZ has the following vertices. Find the coordinates of the vertices after each dilation. All right, so centered at the origin, k equals 4. So this is going to be an enlargement. Both of these are going to be enlargements. This one's going to be 4 times as big. This one's going to be twice as big. Right, so remember the formula is kx, ky. So it's going to be 4x, 4y. Okay, very simple for the origin. So now you're going to plug in. So we get 4 times 3, and negative 4 times negative 4. Oh, I'm sorry, not negative 4. Positive 4. 4y, and then y is negative 4. All right, remember this is x and this is y. All right, so we have 12, comma, negative 16. All right, remember this is x, this is y. And so we are just doing 4 times 6, and then 5 times, sorry, 4 times 5. All right, so we get 24, comma, 20. All right, and then last one, we get 4 times 8, 4 times negative 2. It gives us 32 and negative 8. All right, that's it. Now this one over here on the right, we're going to use the formula, right? So we got k is 2, and we're centering it at y. Okay, so that means this is y. So that means you have 6 comma 5. That's going to be your a, that's going to be your b. All right, so then using the formula, right, it's k times x minus a plus a. So we have k, just 2, x minus a plus a. All right, and then we got k again. Then this time's gonna be y minus a, right? Plus a. All right, here I'm gonna make this use that color. All right, here's gonna be y minus a plus a, or y minus. Oh, this should be b, not a. B. Okay. Let me erase it. Change it to a b. All right, there you go. Okay, so we got B, we got A, we plug it in. All right, so let's do that. Let's plug it in. Now A is 6, right? So we can replace that. So let's go ahead and replace that. So we get 6 here, 6 here, and then 5 here, and 5 there. All right, and again, if you have more space, then you can replace it. But here I had to erase it because I'm out of room. So I'm gonna distribute this, distribute that, okay? And I'm gonna do it up here where I have a little bit more room. So here I'm gonna do it over here. So 2 times x minus 6 plus 6. Distribute that. That's gonna be 2x minus 12 plus 6. Okay, and so that will give us 2x, negative 12 plus 6 is negative 6. So 2x minus 6. All right, now this one here is 2 times y minus 5 plus 5. We're going to distribute this. That's going to be 2y minus 10 plus 5. Negative 10 plus 5 is negative 5. So we got 2x minus 5. There you go. Now we got our coordinate rule. So there should be a parentheses there. All right, remember this is x, this is y. We can plug it in. So we got 2 times 3 minus 6. And then I keep saying x here. This is y. I don't know why I keep saying that. Sorry. 2y minus 5. All right, and then negative 4 minus 5. All right, so let's do the math. We got 6 minus 6 is 0. And then negative 8 minus 5 is negative 13. All right, then the next one. Again, this is x, this is y. So we got 2 times x, which is 6, minus 6. And then we have 2 times y, 5, minus 5. And so that gives us 12 minus 6 is 6, and then you got 10 minus 5 is 5. Again, it's the same coordinate. No surprise there because we're centering it at y. All right, and then here we get 2 times 8 minus 6. Again, plugging in for x there. And then this is y. Now we're going to plug in for y. 2 times negative 2 minus 5. And we get 16 minus 6, that's 10. And then negative 4 minus 5 is negative 9. Right, those are your coordinates. All right, so example 4. Now we want to describe a dilation. All right, so this time they gave us the two triangles, right? The pre-image and the image, and they didn't give us the coordinates, but they give us a graph, which we can find the coordinates from the graph. And then they said, okay, A prime, B prime, C prime, that's the image after a dilation. So obviously it went from this small one to this big one, and therefore it's it went from here to there, right? And so therefore it is a reduction. So we know we have a reduction. I'm sorry, not a reduction, an enlargement from small to big. Okay, so that's an enlargement. So let me put in here, it's an enlargement in this case. From small to big. And what we want to do is we want to write a coordinate rule to represent the dilation. And so Okay, so first we're going to describe it, which we said it's an enlargement, but we're going to describe how by how much. We want to find the scale factor. How large of a scale factor is it? Is it 2 times large? Is it k equals to 3? What is it? And then we want to figure out, okay, where is it dilating from? Is it dilating from the origin or is it dilating from somewhere else? And then we can write the coordinate rule. All right? Okay, so let's go ahead and start. Okay, so first thing we're going to do is we're going to identify two sides on the both triangles, in the image and the pre-image. So the image a prime b prime, we're going to need to figure out the length of that. So what we're going to do is we're going to try to find the length of this, and we're going to try to find the length of this, and we're going to compare them to see what the scale factor is. Okay. So remember, in order to find the distance, we need the distance formula to figure out the length. Okay. All right, so the coordinates for A, let's write down the coordinates. So A, the coordinates are um, here it looks like so we gotta be careful because this is the origin. This is so if you were to like graph it, that's the positive x-axis. This is the negative x-axis. So this is negative x, okay? So it's going because this is 0, okay? So this is actually -1, -2, -3. This is actually -3, comma 0. All right, so just be careful with that. And then 4, 5, 6, 7, 8, 9. This is -9, comma 0. Okay. All right, and then here, the coordinates of B, 0, comma 2. Right, so that's the coordinates of B. And then here, 1, 2, 3, 4, 5, 6. So 0, comma 6. All right. So now we know what the coordinates of A and B are, and I'm going to write them down here again, just so that we have them for reference. So this is A, and then let's do B. All right, so those are our coordinates, and now next we're going to do the distance formula. Okay, so this is going to be x1. So subtract the two x's, subtract the two y's. Okay, so let's subtract the two x's first for the distance formula. So AB is equal to the square root of 0 minus -9. So again, subtract the two x's. 0 minus -9 squared. Double negative turns into a positive here, right? And this is a 9. It's hard to tell, so I wanted to redraw it. And then plus, and then now you're going to do the two y coordinates. So 6 minus 0 squared. All right, and then we have square root. 0 plus 9 is 9. So we get 9 squared plus 6 squared. Okay. And this is A prime B prime, so not AB. So let me just call this A prime B prime. Okay. All right. So we got 9 times 9 is 81. 6 times 6 is 36. So we have 81 plus 36. And so we have the A prime B prime is equal to square root of 117. Okay, so we got A prime B prime. Now let's find A and B. So A is -3, 0. B is 0, 2. Okay, so now we're going to find the length of AB. So we're going to subtract the two x coordinates. So we get 0 minus -3 squared. Now we're going to subtract the two y's. 2 minus 0 squared. Now double negative here turns into a positive. 0 plus 3 is 3, so we get 3 squared plus 2 squared. And the 3 squared is 9, 2 squared is 4, so 9 plus 4. And so we have AB is the square root of 13. Okay, so now we're going to find the scale factor. So the scale factor, remember, K is a scale factor. The scale factor is the image over the pre-image, right? So the image over divided by pre-image. So the image is A prime B prime, right? over the preimage is AB. Okay, so we're going to do square root of 117 divided by square root of 13. Okay, so how do we do that? Well, what you can do is you can take the square root and divide 117 by 13. So you can put them under one square root and just divide the two numbers. So 117 divided by 13, that's 9. And so this is going to give you the square root of 9. And so that means the square root of 9 is 3. That means the scale factor is 3. Okay? All right, so now we found the scale factor. So it's multiplying by 3. It's getting 3 times as large. That helps us describe the dilation. But where is it dilating from? That's what we're going to find out. So we're going to use this coordinate rule. Now that we know what K is, we're going to use this coordinate rule, right? Plug in there. And we're going to pick one point, and its preimage and image. So let's go ahead and pick A and A prime, and we're going to try to use these two coordinates in order to figure out with this coordinate rule. Because remember, we're going to go from A to A prime. You can go from B to B prime or C to C prime, doesn't matter. But A goes to A prime, so you're going to pick one of those sets. So let's do A and A prime. So that means A prime is equal to this, okay? So this is what A prime is. Okay, so I'm going to go ahead and write it out. So we know that A prime is equal to this, all right? This is what A prime is. So this is A prime, guys. Okay, so let's go ahead and plug in for A prime. So A prime is equal to this. And let's actually, what we'll do is let's write out the formula. So I'll write it out, and then I'll use the colors, and then we'll replace them. Okay, so we got K here. We got minus A plus A. Okay, so we got K, X minus A plus A. Okay, and of course that's the parentheses. And then we got K again. Then we got minus B plus B. Okay, but we know that A is equal to the or A prime is equal to negative 30, right? Or negative 90, I'm sorry. So we know that that's equal to negative 90. So we're going to be plugging that in shortly. Before I do that, I'm going to simplify this. So let's go ahead and simplify this a little bit. So we get K is, we said K was 3, right? So let's do that. We got 3 times x minus. Actually, what we're going to do, instead of putting x here, we're going to actually replace x. So we know that this is x, this is x and this is y, right? So we're going to plug this in. That's x, right? And then that's y. So we're going to actually plug in x for x and y. So instead of putting x here, we're going to plug it in. So negative 3 minus. Now we do not know what a is. Okay, let me put this in black. So we do not know what a is. A is the center of dilation, which we have no idea where it is, right? So the center right now is A comma B. We have no idea what it is. So we're going to leave it at like that. So we got negative 3 minus A plus A. All right. And then we got K, which is 3. And again, I keep doing the X, and this should say Y, not X. Okay, so again, bear with me here. And then we get Y. Now, Y is 0. So 0 minus, and then we got B plus B. Okay. All right. So that's what we got. Let's clean this up a little bit. Let's clean this up. So we get A prime is equal to distribute this and all that good stuff, okay? That's going to be negative 9, 3 times 3, and then 3 times negative a is 3a, and then plus a. And then distribute this. So it's going to be 0 minus 3b plus b. And so we get that a prime is equal to negative 9 minus 2a, and then negative 3b plus b is negative 2b. Okay? Now, we know what a prime is. A prime is negative 9, 0, right? So we're going to plug that in to here. All right, so let me erase that. So we're going to plug that into here. So we get negative 9, 0 equals negative 9 minus 2a, negative 2b. Okay? Now, notice that this is going to be equal to this, and this has to be equal to that, right? So we have ourselves two equations. So our two equations are negative 9 equals negative 9 minus 2a. And then our other equation is 0 equals negative 2b. All right? So now we're going to solve. Solve this equation. Okay, so how do we solve it? We're going to add 9 to both sides here. Cancel that out. And in this equation, I'm going to divide by negative 2 to cancel that out. All right, so we have negative 9 plus 9 is 0 equals negative 2a. Divide by negative 2 on both sides. That cancels out, and I get 0. So we have a is equal to 0, and b is equal to 0. That means my center has to be, so my scale factor is 3, as we found out here. Our center is 0, 0, the origin. All that just to figure out is the origin, but there it is. And then we can write down the coordinate rule. So the coordinate rule is as follows: x, y maps onto, and well, let's do this, clean this up a little bit. So remember that it was 3 times x. Yeah, so let's plug it in. So using the formula, 3 times x minus a, but a is 0, right? Plus a. And then 3 times y minus b plus b. You see that? So it's just going to be, so if we simplify that, we get 3x, comma, 3y. And there's my rule. So that is the description of the dilation that we're dealing with. All right, a lot going on there. So go ahead and pause the video and see if you can try the check. All right, so let's go ahead and look at it. So let's go ahead and do what we did before, and let's pick 2 points, or two points that we want to focus on. So D here is 1, 2, 3, 1, 2, so 3 comma 2. D prime 6, 7, 1, 2, 3. So it looks like 3 comma 3. 1, 2, 3, 1, 2, 3. Okay, so 3 comma 3. And this one's 1, 2, 3, 4, 5, 6, 7. So 7 comma 3. And then let's look at E and E prime. E and E prime are the same point, right? And so it's 7, 8, 9, 9 comma 3. Now, this is really easy, guys. We don't have to do the distance formula for this. We can, but we don't have to. We can actually count this. We know that DE is simply 1, 2, 3, 4, 5, 6. See that? And then this one is 1, 2. So really, it's 6 divided by 2, or 2 divided by 6, which is 3. So we could do that. However, I am going to do the distance formula just so you can see how it works, all right? Okay, so let's write down the coordinates. So let's do d prime and e prime. So d prime is 7, 3. E prime is 9, 3. And so we can do the distance formula. D prime E prime equals the square root. Subtract the x coordinates, 9 minus 7. Now subtract the y coordinates, 3 minus 3. And that gives us 2 squared plus 0 squared, which is 2. Which that's exactly what I said it was. See, 2. Now let's do DE. So D is 3, comma 3, and E is 7, comma 3. And we said that that was, E was 9, comma 3, sorry. Okay? All right, and if we quickly apply the distance formula, we have DE equals square root 9 minus 3 squared plus 3 minus 3 squared, which leaves you with 6 squared plus 0 squared, which is the square root of 36, because 6 times 6 is 36, and the square root of 36 is 6. There you go. And that's exactly what I said it was going to be. If you look at the picture above, that's 6 spaces. So see, we don't have to use a distance formula for that, but we did. All right, so we got 2 and 6, so that means that we're going to do the k is going to be the image over the pre-image. So it's 2 over 6, which is 1/3. There's my k. We can reduce that to 1/3. All right, so center dilation. We want to um, figure out where the center of dilation is, right? So we don't know where that is. So the center right now is A, comma B. We have no idea. That's what we're trying to find out. We just found the K. The K is 1/3, so we can replace that, if you will. And let's pick some points. So let's pick D and D prime. All right, so we'll call this D. We'll call this D prime. So D goes to D prime. And remember the coordinates for D were 3, comma 3. And the coordinates for D prime uh, were 7 or are 7, 3. Okay. All right. So that's something to keep in mind. All right. So let's start. So what I'm going to do is I'm going to say I'm just going to do this part right here, the K part, K times X minus A part. Okay, so we said D prime is equal to K, and K is 1/3, times X minus A plus A. And what is X? Well, X is going to be 3. See that? So we have 3 minus A plus A. And then we get K. And then y minus b. And what is y? Well, y is also 3. So 3 minus b plus b. Okay. All right. So again, we're gonna distribute all that good stuff. So distribute, distribute. Okay. So we get 1/3 times 3 is 1. 1/3 times a is 1/3. So we get 1/3 a plus a. 1/3 times 3 is 1. 1/3 of b is just 1/3 b plus b. Okay, remember we need a common denominator. This is over 1. So we're going to convert this. We're going to multiply this by 3, top and bottom, because there's an invisible 1 here, right? So this becomes 1 times 3. Let me zoom in on this right here. You can see it. 1 times 3 is 3. So this is 3a over 3. Okay. So this becomes 3 over 3. I'll just show my work here so you can see it. Plus 3/3 a. And then same thing here. 1 minus 1/3 b plus 3/3 b. I did the same thing here as I did there, okay? All right, so then what's negative 1/3 plus 3/3? Well, 3 minus 1, or negative 1 plus 3 is 2. Okay, so it's 1 minus 2/3 a. That's a 3 there. And 1 minus 2/3 b. All right, and now what is d prime? Well, d prime, we can replace that, is 7, 3. And so we have our two equations, right? This is equal to this, and this is equal to that. So we have 7 equals, let's split this up, shall we? Equals 1 minus 2/3 A, and 3 equals 1 minus 2/3 B. All right, so subtract 1 on both sides. Subtract 1 on both sides. And it looks like to get rid of the negative 2/3, you're gonna multiply by 3 and divide by negative 2. So you're gonna multiply by the reciprocal, okay? Whatever you do on one side, of course, do on the other side. Multiply this by the reciprocal. So we cancel that, cancel that. And now 6 times 3 is 18, and 18 divided by negative 2 is 9. So A is negative 9, sorry. And then 2 times 3 is 6. 6 divided by negative 2 is negative 3. So B is equal to negative 3. So it looks like the center of dilation is negative 9 and negative 3. So it looks like our scale factor is 1/3. Our center of dilation, we said, is negative 9, negative 3. And our coordinate rule is xy maps onto, how do we find the coordinate rule? Well, we plug it in, we use this formula here. So it was 1/3 times x minus a. Now a is negative 9, so we're going to plug that in, plus negative 9. Um, and then and then the y coordinate is 1/3 times y minus b plus b, right? So 1/3 times y minus, I'm running out of room here, but b is negative 3 plus negative 3. All right. And then distribute and all that good stuff. This turns into a plus, right? Distribute. And we get 1/3 x. Now, what's 9/3? 9 times 1/3. 9 times 1/3 is 3. And then 3 minus 9 is negative 6. So I'm just going to write this as negative 6. Well, let me just show my work here. Sorry. And then we get 1/3 y. And then what's 3 times 1/3 is 1. So plus 1 minus 3, or plus negative 3. All right, so 1/3 x, 3 minus 9 is negative 6, 1 minus 3 is negative 2. All right, there you go. So there's our rule. Okay, there you go. So a very involved type of problem, but we were able to describe our dilation, scale factor, all that. All right. All right, so let's go and wrap this up. So we said, example 5, it says rectangle has the following vertices. Find the coordinates of its image after a rotation of 90 degrees clockwise about the origin and a dilation centered at the origin with a scale factor of 1/3. Okay, so we got this rule and we got this rule, the dilation. Okay, so the coordinate rule number 1, if we want to rotate 90 degrees clockwise, then the formula is going to be y negative x. You just have to know that formula, okay, or that coordinate rule. And the second coordinate rule is what we talked about in this lesson. If you're centering about the origin, it's going to be kx, right? Ky. But here k is 1/3, right? So it's going to be 1/3 x, 1/3 y. Okay? All right, so let's go ahead and apply that transformation to all of these coordinates. So for w, you're going to switch the coordinates and put a negative on the second one. There you go. And then for the second transformation, you're going to multiply by 1/3. And 6 divided by 3 is 2. Negative 3 divided by 3 is negative 1. There's my coordinate w. Now let's do this one. Switch the coordinates, put a negative on the second one. Follow that up with a transformation, multiply by 1/3. So we have 1/3, 9 divided by 3 is 3. Negative 6 divided by 3 is negative 2. All right, and then the last one. First transformation, switch them, put a negative on the second, and then multiply by 1/3. So it's going to be 1 comma negative 1. And that's it, guys. Those are your coordinates. W prime, X prime, Z prime. All right, pause the video and see if you can try this problem. All right, so let's go ahead and try this problem. Probably easier to actually graph these. So we get negative 2, 1. That's J. K is 2, 0. And L is 1, negative 4. All right, so there's our triangle. And we want to find the coordinates after a dilation centered at K, scale factor of 2. Okay, so scale factor of 2. So that means that we're going to multiply. Oh, and we're doing it about K, right? That's what it says. Centered at K. Okay, yeah. So centered at K. So K is 2, 0. So that means this is my A, this is my B. Okay. So if I apply the formula, it's K times, and this is my scale factor. So it's K times X minus A, which is 2, plus A, which is 2, and then 2 times Y minus B, which is 0, plus B, which is 0. Okay, I'm not going to color code it, but we've seen this problem a few times already. And simplify this, distribute. So we got 2x minus 4 plus 2, 2y, and 2y. The 0 doesn't do anything. All right, so then our transformation becomes xy becomes negative 4 plus 2 is negative 2, and then 2y. So that's our transformation number 1. Transformation number 2 is a reflection in the line y equals 3. That one is not really easy to come by, so I'm not going to write a rule for that, but we are going to transform it using the graph, okay? So let's do the first transformation. We're gonna multiply. So we're gonna plug. This is x. This is y. We're gonna plug it into this formula. Okay. So we have 2 times negative 2 minus 2, and then 2 times 1. So we have negative 4 minus 2 is negative 6. Okay, that's the first transformation. Let's do the next one, k. So we got 2, this is x and y, so plug it in, 2 times 2 minus 2. And then we have 2 times 0. So we have 2 comma 0. And now last one, L is 1 negative 4. So we have 2 times 1 minus 2, 2 times negative 4. So 2 minus 2 is 0, 2 times negative 4 is negative 8. Now we are going to reflect it about y equals negative 3. So y equals negative 3 is a horizontal line, 1, 2, 3, it's right over here. Y equals negative 3. And we actually want to do this for these coordinates. We want to transform these coordinates, okay? So actually, I don't care about these. So you can, I'm going to erase this. You don't have to erase it on your paper, but I'm going to erase it because I don't want to, I don't want to have too many things on my paper, okay? That's just me. That's just me personally. I'm going to take these coordinates, negative 6, and then 2. So that's that point, J. Next one is 2, 0. And then 0, negative 8. 4, 5, 6, 7, 8. All right. So now what I'm going to do is I'm going to reflect it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's where J goes. All right. And the coordinates for J in that case are 1, 2, 3, 4, 5, 6. So 6 comma 6 comma negative 8 looks like. Or negative 6 comma negative 8. All right, and then L is 1, or let's do K. 1, 2, 3, 1, 2, 3. It's got to be reflected. So K is going to be 2, comma, 4, 5, 6, 2, comma, negative 6. It appears. Okay. There you go. And then L is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's L prime. All right, so L prime is going to be 0, comma, and then it looks like 1, 2. All right, there you go. So this is J prime, K prime, L prime. This is your answer right here. All right, that's going to do it for the video, guys. Hope you found this useful and informative. And as usual, I'll see you in the next one.